Hello, it's MRob. I'm here to go over probability and proportions. You've talked about both of these things at least a little bit in 6th grade. And I'm going to use what you used before, and then I'm going to take it to the next level. So let's just dive in. So number 1 says, if 1 out of 5 students forgets their calculator, how many would you expect to forget the calc in a class of 30? 1 out of 5 sounds like a fraction. And I could write that down as a fraction, but I'm going to do every one of these questions with a different method. And then you can pick which method you like the best. So I'm going to pick graphing for this one, and because I'm picking graphing, you are going to graph also. Whatever I write, you write. We need to practice all of these things. You never know when I might give you a graph and you have to read it, so let's practice. We have a y-axis and an x-axis. A lot of times I like to use a table to make my graph. So I don't know what to label these axes yet, and I need to give it a title. So it's all about the calculator, so this is my title, calculator. And we're comparing the number of students who forget their calculator to the number of total students in the class. So it said 1 out of 5 students forget their calculator. So 1 student will forget it, and that would mean there would be 5 total students. If we're going to keep with that ratio, if 2 students forget their calculator, that would be doubling this, or 3, that'd be tripling this, or 4, etc. Let's plot that. So I got quite a bit of room down here. We'll start at 0. Your graph doesn't have to be perfect. I know I didn't give you graph paper. Down here would be number of forgetters. I am probably not going to spell this right. You guys tell me if I spelled that right. Forgetters, forgettors. I'll have to Google it. Well, apparently I Googled it and there's a rock band called Forgetters. So I'm going to use these lines so it's nice and neat. And I don't always have to count by what you see here, but it would be easier. I got to count by something uniform. So if this space is 5, then the next space is another 5, and another 5, and another 5. It is a coincidence that's the exact same numbers from my table. So if I have 0 students in the class, there's definitely going to be 0 people forgetting their calculator. If I have 1 student, it would be forgetting. It'd be 5 people in the class. 2, 10, 3, 15. Not every graph looks like this. So when you do graphing, if you make every graph look like this, one of those graphs has to be wrong. So it looks like this. So I want to know, what can I expect in a class of 30? Well, I didn't get to 30 yet. If I was to continue this, the next one would be 25, and 30 would be up here in the middle of my words. Oh well. Here's 25. So I wrote over my problem. No big deal. There's 25 and then 30. So if I continue this, 30 looks like it would go with 6. And does that sound right? Let's continue this. So I got 5, 1 more here, 5 more here, 1 more here, 5 more here. So here it is on the table, and there it is on the graph. Oh, here is 6, 30 on the graph. Here's the answer right here on the table. So I just answered this question using either the graph or the table. Let's look at the next one where I give you the table. Based on the table, in a class of 30, how many students would want gray shirts? This time, this is a proportional relationship. It is a straight line through 0, 0, and it is a constant unit rate. So you can see why this is in my proportionality chapter. I didn't actually write a proportion. but I did have a proportional graph and a proportional relationship or unit rate that is constant. This time I'm going to do a proportion. Proportions are when you have two equal ratios or two equal fractions. And it's very important to label what it is you are talking about. I want, how many students would want gray? And it's out of the students or the total. So based on this table, there are 3 students that like gray out of, what is the total? So the total would be adding it all up. The total 2 and 3 is 5 and another 5 is 10. So that's 3 out of 10 students that like gray. I don't know, so I'm going to put an X here, how many would like it out of 30. And you have done proportions like this in 6th grade, and we do them with equivalent fractions. And you ask yourself, how do I go from 10 to 30? Now remember, proportional relationships are based on multiplying, which can also be related as dividing. Not an adding and subtracting thing. That's not how you get proportional relationships. You're either going to multiply or divide by something. So in this example, you have to multiply by 3 to get 30. So whatever I do in the bottom, I have to do on the top because it's equal. It's equivalent. 3 times 3 is our answer. Our answer is 9, which means we have 9 students that we can expect to want a gray shirt. And this is all old stuff. We've done all this stuff before. So let's look at number 3. If you roll a die, which by the way is the singular word for dice, if you don't say I have 1 dice, you say I have a die. And it's 54 times, I do this 54 times. How many times are you likely to get a 2? So I'm going to set up a proportion. And I'm going to label what it is I'm looking for. Labeling helps you focus. Step 1 is to label. Make sure you are checking out your mega notes. This is a nice summary for you to go to when you need help. I want to get a 2, and I got another, again, total on the bottom. Out of the total times, how many times will we get a 2? Well, if you look at a die, it has how many sides? It has 6 total sides. How many of those sides have 2 dots on it? And only 2 dots. That would be one side. 1 out of the 6 sides is the number 2. How many times will you get a 2 if you're going to do this 54 times? Now, I'm sure you can do this answer exactly the same way we did the last one, but we're in 7th grade now, so I'm going to teach you another method. This other method is called cross multiplying. So I'm going to pause what I'm doing right now and refer back to the notes that you were supposed to have read. These notes talk about proportions. Again, a proportion is an equation where one ratio equals another ratio, and a ratio can often be written as a fraction. So this is an example of a proportion. This has 2 ratios, but they're not equal. They're getting multiplied. So try not to get these 2 things confused. I write this down because students often start to do things you're supposed to do for proportion, like I'm going to teach you, and they start doing it when you're supposed to just regular multiply. These are not 2 equal fractions because there's something else here. There's a +1. That's additional stuff. None of these are examples of proportions. This is a regular times problem, a regular divide problem, and this is a whole other type of equation altogether. So you have your number 1 thing you need to do is label, and always make sure that the units match. Most common mistake to why students get questions wrong is they don't label. They just start throwing the numbers in and they're not matching units. Okay, we have to matchy-matchy for it to be equal. So there's 2 ways to do this. You can do it the way you did in 6th grade, especially when the numbers are easy. You can just do equivalent fractions. You multiply or you divide by a number to get the equivalent fraction. I wrote 1 down because anything over itself is 1. So I did 3 over 3. That's a 1. That's a special 1. The 1 depends on what the problem is. And then there's a new way I'm going to teach, which is called cross multiplying. and you make this butterfly. You multiply this on one side. It doesn't matter which one. You multiply this on the other side. So I want to explain, why does that work? So if I had 2 over 4 and it's equal to x over 5, it's a good idea to cross multiply because I don't know what to multiply 4 by to get 5. You might be able to find the unit right, but it might be an ugly number. Let's avoid the ugliness, okay? So I want to go over this for a second. What is the opposite of dividing by 4? Because remember, opposites will undo each other. Right, the opposite of dividing by 4 is multiplying by 4. So if I multiply by 4, over here, these will be gone. And if I multiply by 4 over here, I'll have x over 5 times 4. What's the opposite of dividing by 5? It's multiplying by 5. If I do it on the right side, the 5s will divide off. If I do it on the left side, I'll have 5 times 2. So basically, what I'm going to do is some algebra, which we'll get deeper into later. Opposite of dividing is multiplying. I didn't write down all the extra steps because it's a lot simpler looking. Since when I multiply by 4, these divide off, multiply by 5, these divide off, this is all I'm going to be left with. I get this from what we call cross multiplying, and I only cross multiply when I have a proportion. I do not cross multiply for any of these types of problems, okay? Only when I see one fraction equaling one fraction. So a lot of the times I would let students in the past cross multiply. 2 times 5, you get 10. 4 times x is 4 times x. You don't know what that is, so you just copy it down. And then 4 times what is 10? Well, to figure out what to multiply by, you divide. So 10 divided by 4 will give you my answer. And this is okay, but this is the much better algebraic way to write it down. So 2 times 5, 4 times x, still equal. Simplified, 2 times 5 is 10. This doesn't get any simpler. 4 times x is 4 times x. The opposite of times 4 is divide by 4. Opposites get rid of each other. Just like I did it over here, I'm just writing it more technically. I want us to get here because we're going to be doing a lot more algebra later in the year. So if I divide by 4 on the right, I also divide by 4 on the left because this is an equation and I have to do equal things to each side in order to keep it equal. 10 divided by 4 is 2.5. You can either write it as a mixed number or you can write it as a decimal. So I want you to reread that. Reread it a couple times and don't just look at it one day. Go back to it another day too. So over here, back to the example I was on, I could do it in equivalent fraction way, but I'm going to practice cross multiplying. I have one fraction equaling another fraction, one ratio equaling another ratio. It's totally a proportion, so it's totally legal to cross multiply. So I just circled those. I'm going to multiply those. They're across from each other. I'm going to hurry up and write the equal sign down because a lot of times people forget to write the equal sign down. And then 6 times x is very simply 6 times x. Okay, let's simplify this. 1 times 54 is that. 6 times x is 6 times x. 6 times what is 54? You can probably tell me. You can probably just guess it. But I don't want to guess, even though you know the answer is right. You can check it. I want to show the work. The opposite of the times, this is an implied times here. I don't have to put that dot there, but it helps. If you put the dot in, you know the opposite of times is divide. This is my divide line. I'm going to divide by 6, and I'm going to equivalently divide by 6 on the other side. It must be equal things. I'm doing equal things. Anything divided by itself is 1. So I have 1x, which is what I'm looking for. What is 1x? Well, 1x is 9. The answer is I can expect to get a 2 9 times. 9 times. Now, this is probability. It's not certainty. I don't know if I roll a die 54 times I'm going to get 9, but I'm going to guess that I can. Okay, if I had to make a guess. Okay, and that was your lesson on probability, solving a proportion with cross multiplying while going over some of the other topics from 6th grade on equivalent fractions, graphing, tables, and a little bit of probability. Reread these notes. See you later.